Hi everyone! In this video I'm going to explain how sine and cosine work in the unit circle with angles in standard position. So you might have heard in past years that sine is the opposite over the hypotenuse and cosine is the adjacent over the hypotenuse. And I mean, those are fine if you're thinking about triangles that you're actually physically drawing. Those are fine ways of understanding sine and cosine. But they aren't very useful when you're thinking about rotations around the Cartesian coordinates. So like in particular, if we're talking about a rotation up to like there isn't really a triangle there, right? This is just sort of the idea we've rotated some number of degrees. Let's call that theta. Theta, by the way, is a Greek letter. It looks kind of like a cursive O. That's theta. And for whatever reason, we often use these Greek letters for angles in math. So if that's our rotation of theta from our 0 degrees on the x-axis, then we want to be able to talk about this point here. And so I ended my last video talking about the unit circle. And so the idea of the unit circle is what we're going to do is we're going to put that point on a circle with radius 1. So this is my unit circle, which, if you'll recall from the last video, means it has radius of 1. And so that means at this point here, we could actually label as 1, 0, right? Because that's x first, and if it's got radius 1, then that is 1 to the right. And this point up here, we could label as 0, 1, because that's a point that's straight up. And then the question is, how can we label this point here? And this brings us to the definition of sine and cosine in the unit circle. So what we're going to do is we are going to define cosine and sine in terms of a triangle, a right angle triangle, that we're going to construct up to this terminal arm. Okay? So this terminal arm, because it's a unit circle, this goes from the middle of the circle right to the edge of the circle. The length of the hypotenuse is 1. And then we're going to define cosine to be the x-coordinate of the rotation theta. So this is cos theta is the x-coordinate of that point. And then sine theta is the vertical piece, sine theta. And you can actually define sine and cosine this way. So cos theta is the x value of a rotation of theta degrees in standard position. And sine, you can then define the exact same way. So sine theta, blah, 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 is the y value. And then, right, the exact same thing. Okay, so you can actually think of this, right? Maybe we should put a box around it because it's a definition. But cos is the x-coordinate of a point on a terminal arm of the unit circle in standard position. The x-coordinate is cos, and the y-coordinate is sine. And so it turns out that there are some particular points on the circle that we can actually find the exact value of using some, middle school to early high school geometry skills. So let's see if we can figure some of these out. Let's say we have a 30-degree triangle. I'm only going to draw my first quadrant, sorry. So let's say we've got 30 degrees, okay? And we're trying to figure out this triangle here. So it turns out that if this is 1, is there some way that we can figure out the height and the width of this triangle? And what we're going to do is we are going to construct an equilateral triangle. Okay, equilateral triangle means 1, 1, and 1. And all that I'm going to do is I'm going to split this triangle in half. Well, look at this. If this is, so an equilateral triangle has 60 degrees everywhere, right? If I split 60 degrees in half, what do I get? I get 30 degrees. and 30 degrees. So I've got a triangle, a right angle triangle with hypotenuse 1 and 30 degrees. Right angle triangle with hypotenuse 1 and 30 degrees. So this triangle here is this triangle here. Well, and so this is half of 1. So this is a half tall. So that means that this vertical component here is a half. So by definition then, we know the vertical piece is 1/2, which is sine of 30 degrees. So sine of 30 degrees is a half, right? Because the y coordinate of a point on the unit circle is the sine of the angle. And in this case, our angle is 30 degrees. And so the sine of that is 1/2. Now, cos is a little bit of work. We're going to have to do some Pythagorean theorem for this, right? So we know that c squared equals a squared plus b squared. We're trying to solve for an adjacent side. So b squared is c squared minus a squared. Now, our hypotenuse is 1. So 1 squared is 1. Minus a half squared is a quarter. So b squared is 1 minus a quarter is 3/4. And so what we need to do is square root both sides. And we get b is root 3 over root 4, which is root 3 over 2. Cool. So that means that this adjacent side in this triangle is root 3 over 2, which is the x-coordinate then of this point, right, because it's this far across. And the x-coordinate of that point is the cosine of 30 degrees. And so we can actually get the exact value, like in radical form, right down to infinite precision for sine and cosine of 30 degrees. And then if we take the exact same triangle and we flip it the other way, right, then we get a 60-degree triangle. And then our short side is a half, and our long side is root 3 over 2. And so that means that in our, if we extend this down to the x-axis to put this on a unit circle, right? So if this is our y-axis and this is our x-axis, the point here is 1/2 across and root 3 over 2. And then this is cosine 60 degrees, and this is sine 60 degrees. Cool. And it turns out there's one more sort of special triangle we can do. So let's do that down here. And that is the 45-degree triangle. Okay, so if this is 45 degrees, and this is, put this on a unit circle, because why not? Okay, the question is, what are the coordinates here? So this is going to be cos 45 degrees, right, because that's the x-coordinate, comma, sine of 45 degrees. Okay, and same as last time, this is a right angle triangle. Our hypotenuse is 1. And because this is a 45-degree triangle, that means it's isosceles. So these two things are the same. Okay, you with me so far? So we have an isosceles triangle. Let's label both of these, I don't know, let's call them n, I guess. So what is the value of n? Well, 1 squared is n squared plus n squared. So 1 is 2n squared. So if I divide by 2, I get a half is n squared. And if I square root both sides, I get root 1 over root 2 equals n. I'm going to switch n over to the left-hand side. And we need to rationalize our denominator. You guys remember this thing? You can't have a radical in your denominator. You guys remember that from the radicals unit? So this is part of why we did it, for getting ready for trig. So we're going to multiply top and bottom by root 2. So root 2 times root 2 gives us 2 in the denominator, and root 2 times root 1, well, root 1's just 1. So this is root 2 over 2. So that means that this is root 2 right? Root 2 over 2. And this down here is also root 2 over 2 because it's isosceles. So this is root 2 over 2, and this is root 2 over 2. Okay, so those are our special values. So our first triangle was, we ended up with halves, root 3 over 2s, right? Halves, root 3 over 2s. And down here, we ended up with root 2 over 2s. Okay, so let's put all that together. The next thing that we're going to care about for putting these pieces together is not just the top right quadrant. So we filled this thing in here. This was 30 degrees. This was 45 degrees. This was 60 degrees. But we want to talk about the entire full circle. So let's figure out how we can label, all of these terminal arms in all of the other quadrants. Now because we're always talking about triangles that come up from the x-axis, we always want to think about our angles as coming from the x-axis. So yes, straight up is 90 degrees, but we don't want to think about doing anything from 90 degrees. So usually I don't even label the 90 at all. We're going to label our 0 degrees. We're going to label our 180 degrees, which is straight left, and we're going to label 360 degrees here. Okay? And using the 180 degrees then, we can figure out that this is the same as this angle here, right? This angle here is 30 degrees. This angle here is 30 degrees. So this angle here is 30 degrees back from 180. And 30 degrees back from 180 is 150 degrees. Our next angle is 45. So this angle here is also 45. So what's 180 minus, right, going clockwise is going backwards. So 180 minus 45 is 135 degrees. And then our last angle here is 60 degrees from the x-axis. And so then this one here is also 60 degrees from the x-axis. And that makes this terminal arm 120 degrees because it's 180 minus 60. In this quadrant down here, we're going to go past 180. So this is 180 plus 30 degrees is 210. This one here, we're going to do back from 360. So this is 30 degrees back from 360. This is 330 degrees. In the third quadrant, our 45-degree angle is past 180. So 180 plus 45 is 225 degrees. In our fourth quadrant, we want to go backwards from 360, right? Because 360 is our x-axis. So backwards from 360 then is 360 minus 45, which is 315 degrees. And then our other points, or other terminal arms rather, are down here. 60 degrees past 180 is 240 degrees. And this one here is 360 minus 60 degrees is 300 degrees even. And generally, the only times we ever label the 90 degrees and the 270 degrees is when we actually care about going straight up or going straight down. Otherwise, you want to always go from the x-axis. Okay, so now let's take these angles in standard position, and let's take our special values and see how we can figure out how to label all of these points. Okay, this first one we've done, this 30-degree triangle here has a long x value and a short y value. This 45-degree triangle here has an equal x value to equal y value, and they're sort of your middle size values. Okay, so root 2 over 2 is sort of medium size. And then your tall triangle here at 60 degrees has a short x value and a tall y value. And so essentially you can sort of think of this as half is short, root 2 over 2 is medium, and root 3 over 2 is long. And those are really the only special lengths we care about, aside from 0 and 1, right? Because this point on the x-axis itself is 1, 0, and this on the y-axis is 0, 1. And what's really cool, this is just sort of like a cool math coincidence. You can actually think of these as 0 over 2, or sorry, root 0 over 2, root 1 over 2, root 2 over 2, root 3 over 2, and root 4 is 2. So root 4 is 2. 2 divided by 2 is 1. So just sort of like a funny math coincidence. The 5 values that we care about are root 0, 1, 2, 3, and 4 all over 2. And that gives you your 0, your half, your root 2 over 2, your root 3 over 2, and your 1. Anyway, I find that kind of cool. I love that connection. Like talk about how beautiful and elegant this trigonometry stuff is. That the 5 special angles, these are the only ones, by the way, that we can find directly, is these 5 special lengths right here. And they work out to be a perfect integer sequence of radicals over 2. That was the sound of my mind being blown. I don't know if your mind is blown too. Okay, so now let's go through labeling these points then. This first point here has a long x value. So my long x value is root 3 over 2, and my short y value is a half. So this first point here is root 3 over 2 for its x coordinate, which is the cosine, and 1 over 2 for the y coordinate, which is the sine. This next point here is medium, medium. So it's got a medium x value, root 2 over 2, and it's got a medium y value, which is root 2 over 2. This point straight up is a short length across, so its x-coordinate is short, and its y-coordinate is tall and skinny, which makes this root 3 over 2. So now we can figure out our values in the other quadrants. And this is where it starts to get a little bit tricky. Because now we aren't just going positive to the right, positive up. Now we are going negative because we're going to the left. So this 150 degrees, I'm going to do this one first because this is my 30-degree triangle over here. This one here has a long x value, right? You see how it's sort of a wide sort of short triangle. So 150 degrees is big in the x, but small in the y. So big in the x means it's going to be root 3 over 2. But because it's going to the left, it's going to be negative root 3 over 2. And going up is positive, and it's going up a short length. So short means that it's going to be a half. This one here, our 45-degree triangle, in this quadrant is 135 degrees. And so the cosine of 135 degrees is root 2 over 2, comma, root 2 over 2, but it is negative in the x-axis because it's going to the left. And it's positive in the y because it's going up. And this point up here is short in the x and tall in the y. So 120 degrees is negative short, and the y is positive tall. And we can fill in all the points down here the same way. In this quadrant, we also have negative y values because they're going to be going down. So this point here is going to be negative wide, negative short. This point here is going to be negative medium, negative medium. This point here is going to be negative short, then negative long. So our x is negative a half, and our y is negative root 3 over 2. And then bottom right, this is positive because it's going to the right, negative because it's going down, and our going to the right was a long length. So our long length is root 3 over 2, positive because it's going to the right, and then my half is negative because it's going down, and it's a half because it's short. My medium point here is positive medium size, negative medium size. And my last point down here is positive short, negative long. Okay, those are all of your coordinates for sine and cosine in standard position. So this means that we can then figure out all of our sine and cosine of all of these things. What is cos of 30 degrees? Well, cos of 30 degrees is the x value of this point here. It's positive and it's long because it's sort of a short, wide triangle. So cos of 30 degrees is positive root 3 over 2. Sine of 30 degrees is positive because it's going up and it's a short one. So it's positive a half. Let's do cos of 330. 330 is down here. Cos is positive wide because it's going way over here. So it's again root 3 over 2. And sine of 330 degrees, that's this point here, is going down, but it's only going down a little bit, right? That's sort of your short triangle. So that's negative short side. Let's do cos of 225 degrees. Cos of 225 degrees is here. So that's negative medium size. Let's do sine of 120 degrees. 120 degrees is right here because it's 60 degrees back from 180. And it's tall and positive. Tall and positive is root 3 over 2. Let's do sine of 300 degrees. Sine of 300 degrees is down here. That's negative tall, right? Because it's 60 degrees back from 360. So that's your 60 degree triangle, which is your nice tall triangle. And it's negative, so it's negative root 3 over 2. So what I'd like you guys to do right now, I've assigned some practice with sine and cosine only in standard position. I'd like you to go through and try to just figure out, based on where your angle is, right, where your angle is from 0, from 180, or from 360, figure out if you're going to end up with a tall triangle, or if you're going to end up with a wide triangle, or if you're going to end up with a medium size triangle. And then based on that, you should be able to figure out if you're going positive or negative in your x and your y, depending if you go right or left, or up or down. And then your values are always going to be half if it's like a short length, root 2 over 2 if it's a medium length, or root 3 over 2 if it's a long length. Okay? I wish you success with your practice. Quick addendum to the video. I realized after I finished recording that I didn't talk about vertical and horizontal points when we were going through these examples here. So let's do, for instance, sine of 0 degrees. Sine of 0 degrees is this point here, which is straight horizontal, right? No rotation at all. And no rotation at all means the vertical hasn't changed away from 0. And so sine of 0 is 0, and cos of 0 then would be 1. And if we have this point straight down here, that is 270 degrees. So what is sine of 270 degrees and cos of 270 degrees? Well, our sine is straight down. And since this is a unit circle, it's going to be 1 straight down. So that's negative 1. And our cosine, we haven't moved horizontally at all, right? We haven't gone right, we haven't gone left. So that is 0 change in our cosine. And so that is 0. Okay, similarly, back here, our cosine would be negative 1 and our sine would be 0. And straight up, our cos would be 0 and our sine would be 1.